Welcome to today's lecture. Myself Tukur Gupta, Assistant Professor from EC Department of Ajay Kumar Garg Engineering College, Ghaziabad. The subject I am covering in my lecture series is Embedded System, which is open elective being taught in 6th semester in all the branches. Subject code is KOE 062, and today the topic that I am going to cover in this lecture is selection of processor and memory devices. So, when we are designing any embedded system application, so what is the first most important thing that we should keep in mind is the selection of processor, that which processor we are going to use in our application. So, there are certain factors which we have to consider before making selection of our processor. So, let us have a look at these factors. First is the performance considerations, next is the power consideration, next is peripheral set, then operating voltage, then specialized processing units, and last is the cost, that is price. So, let us go into details of all these factors one by one. First is the performance considerations. The performance speed of a processor is dependent primarily on its architecture and its silicon design. As we know that since many years the scientists, the researchers are working on the fabrication techniques to find out that which fabrication technique can give us the most efficient systems. So, the evolution of fabrication techniques helped packing more transistors in the same area, thereby reducing the propagation delay. So, when the packing density is more, then the propagation delay reduces. Also, presence of cache. So, this is another important factor. The presence of cache reduces instruction and the data fetch timing. What is cache? Cache is the memory which temporarily stores the data and the code and which speeds up the processing. So, the cache memory plays an important role in any application. Next is the pipelining and superscalar architectures. So, what is the pipelining? In many of the advanced processors, the pipelining is a scheme through which the multiple processes takes place at the same time. So, the multiple instructions can be executed in pipeline parallelly. So, pipelining is a part of parallel processing. What is superscalar architecture? So, these are the architectures of the processors in which the multiple instructions, or we can say the multiple pipelining schemes can be implemented at the same time. So, that those architectures are termed as the superscalar architectures. So, these pipelining and superscalar architectures further improves the performance of the processor. How? By processing the multiple instructions at a time. Next is the power considerations. So, power analysis is a very important feature when we are designing any VLSI application, or we can say when we are designing any embedded application. Increasing the logic density and clock speed, these two things have adverse effect on power requirements. So, when we are focusing on the more and more logic density and when we are focusing on the more and more clock speed, obviously we will require more power. So, a higher clock implies faster charge and discharge cycles. We know the clock is dependent upon the charging and discharging of charging and discharging of capacitor. So, when the charging and discharging cycles are more, then it leads to the more power consumption. More logic leads to higher power density, thereby making the heat dissipation difficult. So, when there are the more and more logic circuits within a chip within the architecture, then it will lead to the higher power density and thereby making the heat dissipation a challenge. Further, with more emphasis on greener technologies, what are these technologies? Which are focused on making more and more efficient systems, which are power efficient, which are area efficient. So, these technologies are basically battery operated. So, to make the system battery operated, we have to make sure that they consume less and less power. So, this is another factor. Peripheral set. What are the peripherals? These, apart from the main processor or the coprocessor, we are having many components, or we can say we are having many devices along with the main processing unit, which makes up an embedded system. So, these are termed as the peripheral devices. So, apart from processor, many other peripherals for input and output operations are there in the system. Since in an embedded system, almost all the processors used are SoCs. What are SoCs? System on chips. Yes. So, to make the systems, to make the applications more and more compact, means when we are considering the handheld devices, we know that it should be compact enough. So, to achieve such challenges, the system on chips are important. So, it is better if the necessary peripherals are available in the chip itself. Okay. This offers various benefits compared to the peripherals in external ICs. So, instead of using all the external ICs for different peripherals, we are implementing the peripheral devices on the chip itself. This saves the area, this saves the processing speeds and makes systems more and more efficient. Next is the operating voltages. Each and every processor will have its own operating voltage condition. Yes. So, when we are taking different processors for different applications, some processors work at 5 volts, some processors work at 3.3 volts and different ranges. So, when we are designing any application, we have to keep in mind, we have to make a note that what voltage range is required for our application, and accordingly we have to use the processor. Otherwise, what will happen? Suppose our system is valid for the 5 volts range and the battery or the power supply that we are using is 3 volts. So, we have to make sure that that 3 volts supply has to be converted for the final 5 volts. So, we have to use some converters. So, we have to use some amplifiers. So, what it will lead to? It will lead to more and more overhead. So, this has to be avoided. So, to avoid this, what we have to make sure that we know the operating voltage conditions. So, it is cheaper to work with the 5 volts microcontroller when the input supply is 5 volts obviously. So, when we are provided with the 5 volts power, input supply, we have to make sure that the processor that we are going to use in our application should be dependent on the or should be operable on the 5 volt supply. And if a 3.3 volts microcontrollers are used, then when it is possible, when we are using batteries. So, these are the two different conditions of using the operating voltages for different types of microcontrollers. Now, we are talking about the specialized processing. So, one is our main processor that we have considered for our application. Apart from the core, presence of various coprocessors and specialized processing units can help achieve necessary processing performance. The coprocessors are needed when we want to process the specialized operations. They execute the instructions fetched by the primary processor thereby reducing the load on the primary. So, when we are having any specialized functions in our application, it is better to use the specialized processors for that, because when we are using the specialized processors for those special functions, then what will happen? It will reduce the load on the main processor. So, the processing of the applications, processing of various functions involved in the application can go on smoothly. So, this will decrease the load on the main processor and also increase the performance. Let us have a look at all these coprocessors, specialized processors. So, first in this category is floating point coprocessors. What is this? So, we know that there are two types of architectures, one is the RISC processor and the another one is CISC processor. So, when we are talking about the RISC processor, that is a reduced instruction set computer systems, then the core of the RISC processor supports primarily integer only instruction set. So, the RISC processors are capable of handling only integer type instructions, integer type processes, but not the floating point processes. Hence, the presence of the floating point coprocessor can be useful in this case. So, it is very helpful in applications involving complex mathematical operations, including multimedia, imaging, signal processing. As we all know that today's in the advanced applications of VLSI designing, we come across the signal processing applications, multimedia applications. So, in all these applications, we need the mathematical operations to be executed. And to fulfill this, we need some coprocessor which is highly capable of processing these complex mathematical operations. So, for that we need a coprocessor, that is the mathematical coprocessor, and which is capable of especially handling these floating point operations. So, for this we need floating point coprocessor. Next is the graphic processing unit, that is GPU, which this is also called the visual processing unit, and it is responsible for drawing the images on the frame buffer memory to be displayed. So, this is very important visual processing unit, and with the increasing graphic requirements such as the textures, lighting, shaders, etc., GPUs have become a mandatory requirements for mobile phones, gaming consoles, etc. We know with the advanced handheld devices, we are having those mobile phones and different gadgets which are having very advanced graphics display, and for that purpose we need the special processors which can handle the graphic processings. So, for this we need graphic processing unit. Various GPUs like ARMS, Mali, then Power VX, OpenGL, etc. These are increasingly available in high end processors. Choosing the right coprocessor can enable smooth design of the embedded application. So, we have to take care that wherever the advanced operations are involved in our applications, like there is the graphics designing, or we can say the floating point operations and complex mathematical operations. So, we should include some coprocessor for those special applications in our systems. This will make the system smooth, more efficient, time saving, power efficient. So, then in this category there is another digital signal processor. The processor, this processor is designed specifically for signal processing applications. So, in today's very advanced VLSI applications, DSP plays a very important role. They are either available, these chips are either available as the part of the SoCs, that is system on chips, or separate in an external package, like externally it is available as the chips also. These are very helpful in multimedia applications. They can be used along with the processor or as the main processor itself. So, these were the specialized processing units used in our systems. Wherever the complex operations are involved, we have to make sure that we are also using the coprocessors along with our main processor for handling these complex functions. Next issue, that is we can say next point to be taken into note when selecting the processor is price. So, it is better to have some extra buffer in processing capacities to enable enhancements in functionality without going on for a major change in the design. What it is saying, that suppose we have designed some application and we have we want to upgrade the application, we want to upgrade some processing of our processor that is used in our application, then how will we do? Do we need to replace the processor? No, it is not always necessary. So, we can upgrade by adding some functionality into our processor, and that should be cost effective. That is it. The price is an important part of any embedded system application. So, while engineers, especially the software and the firmware engineers, will want to have all the functionalities in the system, right. So, whenever we are designing any embedded system application, we will want to have all the functionalities to be fulfilled in that design. So, that in that case the price will be the determining factor when designing the system and choosing the right processor. So, according to the application, we should select the processor very so wisely that it should be cost effective also. Though it should be having all the functionalities within it, there should not be any and also there should be some scope that without investing much cost it can be upgraded, and also it should be complete in itself, so that no extra cost is needed to be invested again in case it is not fulfilling any functionality which has been claimed by it. So, the processor should be effective enough. So, these now how will we select the processor? Let us have a look at this table. This table is showing that how the various features can be implemented in any embedded application, and how we can decide that the microprocessor is to be selected or the microcontroller is to be selected. So, as I have already discussed in the previous lectures that when we are designing any embedded application, so if that application is very precise in its role, then we can make use of microcontrollers, because because microcontrollers are not flexible enough. If we know the precise functioning of our application and that is very limited, then we can make use of the microcontroller. But on the other hand, our application is very general in its role and it can be used for different purposes in its domain, then the microprocessor is the better option. So, let us have a look at this, that if we want to have the feature of Bluetooth in our design, then we can go for microcontroller. Similarly, if we want to include the Wi-Fi in our system, then we can go for any of the microcontroller or the microprocessor. Next is if we want to include the cellular feature, then again microcontroller. Similarly, is the case with sensors, GPS, motors or solenoid control, then SD camera. Then again if we are using HD 720 pixels camera, then any of the microprocessor or microcontroller can be used. And similarly, the microprocessor is a better option for HD 1080 camera. AMOLED display is to be implemented than microprocessor, or the STM series microcontroller is better idea for that. USB 3.0 can be implemented using microprocessor. Then similarly, the real time processing and the long battery life are the features which are possessed by the microcontroller, and the microcontroller should be used then in that case. Again, advanced data processing, graphical user interface and third party network connectivity. These can be easily implemented using microprocessors. So, in this way we can differentiate that which applications or the features can be implemented using microprocessor and which others can be implemented using microcontroller. Here I have shown some examples for that. The slower speeds of a microcontroller translate to less current consumption. That is, Arduino Uno consumes a maximum current of around 45 milliamperes, whereas a Raspberry Pi 3 consumes around 580 milliamperes. So, in this way, if the speed is slow, then the current consumption is also low. If we want to increase the speed of our device, then we have to compromise with the power consumption. So, there is always a trade off between the power consumption and the speed of the system. Advanced graphical user interface, it requires significant processing speed. Yes. So, for that purpose STM32 series microcontroller includes a hardware graphics accelerator, allowing it to be used to create very complex graphical user interfaces. So, in this way we can select the processors. Now, similarly there are the factors which are to be considered while selecting the memory. So, similar to the processor, there are certain factors like speed, latency, memory capacity, size, power consumption and cost. So, when we talk about the speed and the latency, in the case of memory, the speed or the latency means the time to read or write the data to or from the memory. So, speed in general, the speed will not be the greater issue for small embedded applications, but for high end applications the read or the write access time should be faster. So, latency, what is latency? Latency is the time when we give the input and we obtain the output. So, the time gap between the input and the output is known as a latency. When executing the processor instructions, it requests the data speed in the memory. The requested data must be retrieved by the processor for quick operation. So, when there is less latency, obviously the more speed will be obtained. What is the memory capacity? According to the application, we have to decide that how much memory we desire, because when with the increase in the memory size, obviously the cost will increase. So, why to waste our money when it is not needed to be invested in an application? So, according to the application, we should make the choice that how much memory is needed for our application. So, accordingly we have to use. So, suppose we are using the digital camera and we are running out of storage. This is the worst feeling, yes. So, this is just a small example that as in the case of the digital camera, the memory should be good enough, so that we can save more and more photos and videos in our gadget. Similarly, when in any of the application, the memory should be analyzed well before designing the selecting the components, selecting the memory. Size, this size is about the physical size, that the memory unit, the memory chip should be small enough, so that the size of overall physical size of our gadget does not get affected. So, it should be compatible with the embedded system. For handheld devices, the size of the memory should be compact in nature, yes. So, if it is a desktop computer system, the size can be of medium sized. So, when we are using the desktop system, the size is not a big issue. So, proper size selection is very important while selecting a memory for our application. Next is the power consumption. Again, the power is important factor, similar to the case of processor. So, the memory needs power to read or write the data. For high access power speed, the power consumption will be more, the results in the more power consumption. For more heat will be reduce the lifetime of the embedded system. This is another factor. Hence, the designers should go with the optimum power consumption memory devices. Again, this is very important, the cost. While planning to design an embedded system, similar importance should be given to the memory as that of the processor selection. Yes, this is very important. We cannot avoid the memory, we cannot neglect the memory, because all the data or the code that is to be used in our application. So, where it is going to be stored? It is the memory. So, this is very important part, and money should be very wisely allocated while considering the memory. So, we first of all we have to decide that which type of memory can be used in our system, then what is the size of the memory, what is the what should be the power consumption according to our application. After deciding all these factors, then we should focus on the cost also. It should be cost effective too. So, today in our lecture we studied that how should we make the wise decision while selecting the processor and the memory for an embedded application, because both these things are very important. Processor is the heart of any embedded application and memory is its integral part, because all the data and codes are to be stored in the memory. So, the memory and the processor have to go hand in hand. So, the important factors should be considered while making the selection of these two. So, let us in the next slides we will discuss about the details of these memory and processor units. That is all for this lecture. Thank you.